Kia ora Year 11 and 12. I'm making this video for my A-level class to start revising some AS questions. So I'm going to do about 3 questions per video and try and keep it to about 10 minutes. If you're watching this and you're taking AS at the moment, it might be too early in the year for you to have covered all of this stuff. So don't stress too much about it if that's the case. Just come back and watch the video closer to the exam. In this case, I've got 3 questions, and the first one is a binomial expansion. The second one is a trig equation, and the third one's some differentiation and integration. So let's look at this first problem here. We have to find the value of the coefficient of 1 over x. So that means I need to go through this binomial expansion and figure out which term will have 1 over x in it. Now I'm sure I remember that there's a way to find an individual term, but I find it just as easy to start doing the full expansion and just have a look at how that works, especially when I'm near the start of my revision. So we've got 2x minus 1 over x to the power of 5, and I can expand that as follows. It's going to be 5 choose 0 times 2x to the power of 5 times negative 1x to the power of 0, and so on, right? So each term has this pattern where the powers here are going down each time and the powers here are going up each time. So we can see that we don't want either of those two, and if we keep going, the next one is also not going to give me the right term, so I'm not going to bother to clean these up. I'm just having a wee look. Looking at it here, this is going to give me x cubed, and this thing here is going to give me something over x squared. So that's going to simplify to give me an x cubed thing over an x squared thing. So I'm still not where I want to be, which, remember, is the coefficient of 1 over x when I do that expansion. But, happily, the next term will work, and it'll be 5 choose 3 times 2x squared times negative 1 over x to the power of 3. Okay, and then we can just put dot dot dot, we don't care about the rest. So this is the term that we now want to work on. So what's 5 choose 3? Well, there's several ways to work this out. The first way is to say what's the definition of a combination, and that's nice revision for probability, so we'll look at that. So it's this number here, how many ways to choose 3 objects out of 5. And then here we've got 4x squared, and here we've got negative 1 over x cubed. So if I clean all of that up, let's have a look at how this simplifies. So this will be 5 times 4 times 3 times 2 times 1. Hopefully you're remembering that there's lots of easy, cool simplifications that happen in here. So it's going to be times 4 times negative 1. So now we're just getting the coefficient. Right, what's going to simplify? Well, the 3 and the 2 and the 1 simplify, and we end up here with 20 over 2 times negative 4 from this bit, which gives me a coefficient of negative 40. But hold on, I just want to show you one more thing in case you've forgotten. That yes, when I'm doing binomial expansions, of course, I can apply the definition of a combination, right? But I don't have to, because I can use Pascal's triangle to get those numbers very, very quickly. Pascal's triangle is the one that goes like this. So if I'm doing an expansion of something to the power of 5, I'm going to be working with the 5th row of Pascal's triangle. And that is so super fast, right? All I have to do is to go to this row and then just pull out each of these numbers when I need them. So if I were doing a fuller binomial expansion problem, in here I would just get these numbers out of Pascal's triangle. Okay, it's far quicker. But we need to have a really good understanding of the formula for when we do probability. Alright, so that was a very long answer to that first question, but there's quite a lot of stuff to get out of it. Now the second one was a trig equation. We were asked to solve sine 3x plus 2 cos 3x is equal to 0, and we were looking for values in degrees between 0 and 180. So there are a few things to notice here. If you're doing this and you've done A-level and level 3 trig, this should feel really, really easy, but it wouldn't have a year ago. And what we're going to do is use the definition of tan to solve this. Right, so we get sine 3x is equal to negative 2 cos of 3x. Then we're going to divide both sides through by cos of 3x, and we get negative 2. So what does that give me? Well, I'm now trying to solve a really simple trig equation, which is tan of 3x, not 2x, 3x is equal to negative 2. So let's think about what we know about this now that we've done level 3 trig. Well, the period of the tan function is usually 180 degrees, but here the period of tan 3x is going to be 180 divided by 3, which is 60 degrees. So that's a big help because it tells me how many solutions I'm looking for. So let's draw my tan graph. Very badly, but there you go, it's better than nothing. Right, so where are these asymptotes? Well, in the tan of x graph, they're at 90 degrees and then at 270. But in the tan of 3x graph, everything is sped up. So this first one here is going to be at 30 degrees, and then the next one's going to be at 90 degrees, and then the next one's going to be at 150 degrees, and so on. Okay, because the period of the function is only 60 degrees. And I'm trying to figure out when is tan of 3x equal to negative 2. So I'm going to draw in a horizontal line at negative 2. Now I haven't gone far enough out there on my screen, so I'm just going to add one more in because we need to be going right out to 180 to see what's going on. Let's have a wee look. There we go. So I'm going to find my first solution is here, and then I'm going to get two more solutions in that range, but they're very easy to get because the tan function is one where all I have to do is to add on the period to get the next two solutions. Okay, so let's go through with finding the first solution in here. All right, so we've got tan of 3x is negative 2, so 3x is equal to tan inverse of negative 2, and that gives me 116.6 degrees. I don't want 3x, I want x. So the first solution comes in at 38.9 degrees. Now, if you've drawn a good graph, you should be able to see that that makes sense, right? So let's go back up to our graph and have a look. Well, the tan of 3x had its first asymptote at 90 divided by 3, right, which is here. So it makes perfect sense that my value for negative 2 is just past that point, right? Because you can see that if I'm looking in here between 0 and 30, there's nothing in here, right? All of the tan values are positive. So that's my first one. And then I'm just adding on the period to get the next one, and then I can squeeze out one more solution. So we've got x is 38.9, and then x is 98.9 degrees, and then x is 158.9 degrees. So there we go. So 3 solutions and some nice revision of trig functions, right? If you're watching this and you're just doing AS this year, hopefully you understand the idea of how to find the period of a function where it's not just tan of x, right? So the tan function, tan of x, one more time, repeats every 180 degrees, but by going tan of 3x, I'm speeding up the function. Well, that's how I like to think about it anyway. Right, on to the last question, which is actually probably the easiest. And I've got 1 and a bit minutes to go. So we probably won't keep it under 10 minutes, but never mind. So the first one is a differentiation problem, and the second one is an integration problem. And the key to success in both of them is never ever work with 6 divided by x squared. Change that into 6x to the negative 2. And the same thing goes for this one. Right, let's find some room. So we've got y is equal to 4x plus 6 over x squared. Rewrite it with a negative power, 6x to the negative 2. And now we're going to differentiate. So dy by dx is equal to 4 minus 12x to the negative 3. But it would be nicer to write it back like this. 4 minus 12 divided by x cubed. So that's the first bit done. Next we have to anti-differentiate that function. So we don't have any limits of integration. It's just a nice backwards differentiation question. So let's think about what gave me 4x. Well, it'll be something x squared. So 2x squared is going to work there. Plus, now, what have we got here? I've made a mistake, haven't I? That should be a negative 2. Right, so it's going to be something, something, x to the power of negative 1. Right, I'm taking this and I'm going up a notch. I want to end up with a 6. So I'm going to write that 6 down here. But when I differentiate this, I get 6 times negative 1. That gives me negative 6, or take away 6. I don't want that. I want a plus. So this has got to have a multiplier of negative 1. And I also have to add on the constant of integration. Oop, don't know what happened there. Plus c. So cleaning this up, we get 2x squared minus 6x to the negative 1 plus c, which is 2x squared minus 6 over x plus c. So there you go. Right, so that's all for tonight, and there won't be any new videos tomorrow because I'm on strike, but I will try and keep on chugging with some AS revision over the next week or two. Thanks for watching.